Welcome to lesson 7.35 as we look at adding, subtracting, multiplying, and dividing decimals. So we're going to take our introductory look at all these different things, review in many of these cases. All right, let's get started. We have two problems on the board, and that's kind of the pattern you're going to see. I'm going to do the problem on the left together, walk through the steps, and then you're going to do the problem on the right as a sample. Here we go. We want to add these three numbers, together. When we add up decimal numbers, whether they have decimals or not, we want to keep a couple things in mind. First of all, usually we're going to write in the vertical rather than the horizontal. It's a little bit easier. That's my opinion. We want to make sure we line up our decimal place values. And then, of course, if we do get whole numbers, we want to add in the zeros as we need them, right? And so we have some placeholder zeros here, and of course here and here to help us get through this idea to understand how all our place values add up. So we start in the hundredths then, starting on the right. We can really put our decimal in place, and we can do our addition, carry the 1. And we get a final answer. So addition, adding decimals is line up the decimals, put zeros in where we need them, and then of course add. There's your sample problem. Go ahead and give it a go. Okay, next is subtraction. Subtraction really works in almost the exact same way that addition works. We're going to take our numbers and we're going to first line up our place values. And here is where our zeros as placeholders become super important. So I fill that in there so I can understand how to subtract. Now I understand that this 8 can't just drop down. It's 0 minus 8. And so because of that, I have to borrow from the place value here. To get a 1, this becomes 10 then. 10 minus 8 equals 2. Once again, right, my 2 is gone. I have a 1 up here, so 1 minus 8 can't be done, so I have to borrow again. 4, so now this 1 becomes an 11. And I get 3. Decimal, of course, goes straight down. And 4 minus 2 equals 2. So I have that idea important when doing that, especially as the 0 appears on the top, just like that. Okay, here's your sample problem then. Show me you can subtract. From here we move on to multiplication. Multiplication is a slightly different process because the decimals don't need to line up. So as I look at this problem, once again, I just like writing things in the horizontal. I think it's easier to do math that way. That's just my opinion. But as I work with this, I'm going to take this and I'm actually going to rearrange these numbers. I'm actually going to put this on the top using the associative property or commutative property, one of those properties. And I'm going to set it up like that. And I can do that, and that's not going to change the answer by any means. And I did that because since I'm going to ignore the decimals, right? Step 1, ignore the decimal. So if I ignore the decimal, it's really like I'm multiplying 12 times 3. And I can do that real easy. 12 times 3 gives me a 36. Right? Now at this point, as I look at my whole number of 36, I would say that my decimal, what I also like to call the phantom decimal, it's not really there, exists just like that. So we put a phantom decimal in there, just like that. So there's our phantom decimal. And now we get to the next step of multiplying. Multiplying says, okay, now go back and count your decimal place values. So after the decimal. So here's 1, here's 2, here's 3, right? We want to count them on both numbers. Now, because there are 3 decimals place values in our multiplication problem, we're going to use that then to move our phantom decimal to the correct location. Once we have solved for that, then of course we are going to fill in any zeros we may need to get our correct answer. So we have that. And so in the end, our response is, oops, that's not right. I got to read my own stuff. Just like that. Okay, this one's yours then. Looks a little scarier, but you can do it. All right? Just think about the principles of how square roots work. And we'll check your work in class. Finally, our last principle is division. And of course, division is going to follow a similar set of its own little rules. Right? I like to put it in a box. I think it's easier to see and do that way. But I got to make sure I put the right things in the right box, right? This is what is being divided, so that needs to go inside the box. And this is what is on the outside. So we go like that. Now in this setup, we're going to go ahead and we're just going to solve, right? There's nothing we need to do. Now if there's ever a decimal on the outside, which there isn't a decimal, we have to get rid of the decimal on the outside because you can't divide by a decimal number. And so if it was 0.5, for instance, we would move the decimal 1, and then we'd move the decimal 1, right? Just like that, if that was the case. But of course that is not the case in this particular problem. And so we don't have to move the decimal. And so our decimal is good where it is. And so the first thing we're going to do is we're going to move it straight up so we know exactly where it is. Okay, 5 goes into 4 0 times. 5 goes into 48 now. All right, because our decimal is up here now. So we don't really have to imagine it. 48 divided by 5, of course, is 9. 9 times 5 is 45. And we come with a 3. Now we can't have remainers because we're decimals. No, so we bring in our infinity of zeros that exists after any number. And now 5 goes into 30, of course, 6 times. And then, of course, would give us a final answer looking like that. All right, here's your sample. And that brings us to the end of this lesson on adding, subtracting, multiplying, and dividing decimals.